I've described how to make an HTTP request with Android HTTP client, but as I described earlier in this course, the Android development team is no longer improving that system. Because of the size and complexity of the Apache HTTP client on which it's based, the Android development team has been putting all of its future focus on HTTP URL connection, the class that's defined as part of the core Java API and that's also implemented in the Android SDK. So now I'll show you how to replace the Android HTTP client code with HTTP URL connection. I'm working in a project called URL connection, and I'll start in the HTTP manager class that I created previously. The signature for this getData method won't change at all, but I'm going to strip out all of the implementation code and all of the supporting import statements and put in HTTP URL connection code instead. I'll start with a class named BufferedReader that I'll name Reader and initially set to null. BufferedReader is a member of the package java.io, and you'll see that you're using a combination of classes from java.net and java.io to accomplish these tasks. Next, I'll create a try-catch block. Within the try block, I'll create a URL object. This is an instance of the Java URL class, which is a member of java.net, and I'll name it URL. I'll instantiate it by using a constructor method that receives a string, and I'll pass in the URI parameter that was passed into the static method. Next, I'll create the HTTP URL connection. I'll name it con, and I'll get its value by calling url.openConnection. The object that's returned by the openConnection call is a little bit ambiguous, so we need some casting. I'll use a quick fix and add a cast to HTTP URL connection. Now I'm ready to get content from the web. The classic way to use this object is to use a string builder and get one line at a time from the remote site. So I'll create a string builder object, which I'll name SB, and I'll instantiate it with a no-arguments constructor. Now I'll instantiate the reader object that I already declared, and I'll do that with a constructor method for the BufferedReader class. I'll pass in a new instance of inputStreamReader, and for that I'll pass in an input stream that I get from my URL connection. So I'm using three objects: the input stream, the inputStreamReader, and the BufferedReader. Now I'm ready to read the code one line at a time. I'll declare a string variable that I'll name line, and then I'll set up a while loop with a condition. The condition will look like this. First, I'll do an assignment within a pair of nested parentheses, and that will be line equals reader.readLine. That's an assignment, but I need a condition to evaluate to decide whether I should keep on looping. When the readLine method gets to the end of the content, it'll return null. So as long as I don't get null, there's still content to read. Within the while loop, I'll append the line that I get back to the string builder with sb.append, and I'll pass in the line plus a line feed signified with \n. When the while loop is complete, I've received all the content from the web request, and I'll return that content with this expression: return sb.toString. And that's all the standard code you need to make an HTTP request with HTTP URL connection and URL. There's a little bit of cleanup to do here. Just as with my previous code, I need to handle my exception, and in the catch block, I'll call print stack trace and return null. And then I'll add a finally block, and here I'll close the reader object. Now this code takes a few levels. First, I'll make sure that the reader object isn't null. And then within that block, I'll call reader.close. But that call can also generate an exception, so I'll use a quick fix and wrap that code with a try-catch block of its own. And once again, after calling print stack trace, I'll return null. So that's all the code you need, including error handling. Because I didn't change my API at all, that is, I still have a method named getData, which receives a string representing the location of the data and returns the content as a string, I should now be able to run this app without making any other changes to the user interface. So I'll save everything and run, and open the app in my emulator, and when I click the Get Data menu item, the data is requested and retrieved and displayed in the app. So as you've seen, the code required for the HTTP client version is a little bit smaller and a little bit less complex. But this is standard Java code that you're seeing here. There's nothing really different from it in Android than you would see in other Java code. And most importantly, the HTTP URL connection class and its associated classes continue to be improved by the Android development team. For new applications, it's strongly recommended that you use this class rather than HTTP client so that you can get the benefits of future improvements.